May I have your attention, please? We will soon begin AICON 2023 Gwangju third day soon. Participants in the venue, please come inside and be seated. As for smooth operation of the event, please put your cell phones on vibration or silent mode. For the convenience of participants, we are providing simultaneous interpretation. Please pick up interpretation device at the entrance. Please set your channel to number 1 for Korean, number 2 for English. We will begin at 10 o'clock. May I have your attention, please? We will soon begin AICON 2023 Gwangju Day 3 soon. Participants, please come inside and be seated. For smooth operation of the event, please put your cell phones on vibration mode. For the convenience of the participants, we are providing simultaneous interpretation. Please set your channel to number 1 for Korean and number 2 for English. We will begin in short. The third and final day of AICON Gwangju 23, the world's AI to the shining place, has dawned. A variety of sessions will be held today with various global leaders related to artificial intelligence. You can join us online real-time today through KBC Gwangju Broadcasting YouTube channel. Please stay tuned. First, we have prepared special lectures that will open the door of the third day. Robin Colgan, CEO of Jaguar Land Rover Korea, is currently serving as CEO of Jaguar Land Rover Korea after serving as brand director, head of the Middle East Corporation, and president of Asia Pacific at Jaguar Land Rover. CEO Colgan will give a special lecture on the topic JLR's technological environment and the company's response to changing consumer demand. Let's invite CEO Robin Colgan with
안녕하세요. Jaguar Land Rover Korea 대표 로빈 컬건입니다. 반갑습니다. I'm sorry, that is all my Korean, so you'll have to wear. So actually this morning, I am a little frustrated because I spent a lot of time thinking about this presentation and thinking about AI and the application of AI, and I prepared to talk to you all. And on the train this morning, just as an experiment, I looked at ChatGPT, and I asked ChatGPT what were the opportunities and the challenges of AI for Jaguar Land Rover, and it recreated my entire presentation in about 2 seconds. So I thought I could have saved a lot of time, but it's very nice to be with you today, and I'm very happy to have this opportunity to talk to you about our company and our industry. So my name is Robin Colgan. I've been in the industry for 3 decades now. I am not, I must tell you, an engineer. I'm not a technical specialist. My training and my experience is in trying to understand and predict customers' needs, and then to work with our designers and our engineers to meet them. I've, in my career, spent time in our global product development teams for Land Rover, and then I've also spent time working much closer to the customer in market-based roles in the Middle East, in Europe, and in Asia. I'm very happy to be here in South Korea. It's a huge market for cars, it's a huge market for luxury cars, actually. It's the world's 5th largest luxury car market by volume, and we would say almost certainly the 4th largest market for luxury cars by value in the world. So our Korean customers really appreciate cars and luxury cars, and Jaguar Land Rover only builds luxury cars. So this is a very important market for us. So let me start just by orientating the room on the global auto industry, the scale of the industry, and also JLR's position in it. It's an industry which touches all of us. We, I think, all individually have a relationship with cars. It can often be positive for the utility that vehicles convey, the freedom that vehicles can give us, the memories that are formed over the years, often through car journeys. Some of us are passionate about car design and performance. But there are also, of course, negative associations with my industry. There are environmental concerns, there are concerns around congestion, which occasionally happens in South Korea. Of course, there are road accidents. So even for those of us not regularly using private vehicles, the auto industry has a huge impact on the spaces in which we live, and therefore has a big opportunity to improve the impact that it has in those spaces. As an economic sector, automotive is huge. So one global consultancy recently ranked all sectors by revenue and placed automotive sales in 6th position at $3.5 trillion globally, and then ranked automotive manufacturing at $2.6 trillion. So a combined position of 6.1 trillion. Second, as an entire sector, therefore, second really only to telecoms. Now, this scale is something that you understand very well here in South Korea. Your second largest company is, of course, an automotive company. Globally, the industry produced about 85 million vehicles last year. It employs around 14 million people. So for everybody that works for a car company, there's typically 4 or 5 further people working in associated industries. So it has, as an industry, a very significant impact. My point is that whether you are a fan of cars, if you're passionate about cars or not, that cars matter. And cars and changes in the auto industry actually affect all of us. I also mention this question of scale, the size of the industry, just to highlight the sheer breadth of opportunity for AI in all aspects of the auto sector, from ideation through to testing, development, supply chain, and then ultimately to the customer experience. Whilst the debate about the use of AI seems to be gathering pace, AI is already, for us, certainly for JLR, AI is already impacting almost all areas of our business in some way. The research consultants, GMI, estimated that the value of AI in automotive, they estimated it at $6 billion in 2022, and forecast a 55% compound growth rate every year until 2032. Now that's their figures. I can't tell you if that is correct, but I can tell you, as somebody from the industry, that despite the advances that we have made, it certainly feels like we are at the beginning of a journey and that there is much, much more to come. Now, if I just say a quick word about JLR, about my company, where do we sit in the industry? What's our scale? 2 years ago, we launched what we describe as our Reimagine strategy. Our strategy was to concentrate on fewer high-value sectors and develop specialist luxury vehicles that would be built on dedicated platforms. We would transition to BEV, and then we would begin a process of setting and meeting very stringent targets that would transform JLR into a carbon net zero business by 2039. Today, we are a manufacturer that builds, we sell around 100,000 cars every quarter. We would describe ourselves as a specialist manufacturer. We make bespoke vehicles off of dedicated platforms. Our volume is typically biased towards our more premium, our more luxurious vehicles, particularly Range Rover Sport, and Defender. So while we remain a smaller player in volume terms, our business is thriving due to very strong demand for our most premium vehicles. Our reimagined strategy will deliver a new generation of connected, smart, and sustainable vehicles. And of course, that also means the transition to electric vehicles. So next year, we will launch our first full electric vehicle under the Range Rover brand. Our EMA architecture, our mid-sized vehicle electric architecture, will start to deliver fully electric vehicles from 2025, and we expect Land Rover sales to be around 60% BEV globally by 2030. So, having talked a little bit about the industry and JLR's position in the industry, let me just talk a little bit about where we are today. I think it's important to understand that data and connectivity are fundamental to the introduction of AI into the automotive industry. And we are already, the cars that we build, the cars that we sell, are already heavily connected vehicles. There's already a very substantial two-way stream of data from customers to manufacturer to vehicle and back again. We have already transitioned from a world where the engine or the handling of a vehicle were paramount and technology was a secondary consideration. If you think back, it was not a very long time ago that compared to your mobile phone's operating system, every car brand were delivering an interface for the customers which was suboptimal. But that has changed, and it's changed very quickly, and it's changed, I think, really just in the last generation of vehicles that are on the streets just now. We're now in a world where the best handling, the most beautiful vehicle would be barely marketable without a full technology package. That's a relatively recent change. And we see increasingly younger generations of what we might describe as digitally native customers now entering our showrooms. And it's our job to understand and to meet their needs and expectations. The slide on the screen just now shows what we can already do. This is our Defender model, which is currently on sale here in South Korea. So you can see that our vehicles are already highly connected. We can communicate and receive information from our vehicles remotely. Our clients can operate some features of their vehicles remotely, receive information from anywhere in the world. Our ability to diagnose and improve our vehicle through software upgrades that also impact the mechanical operation of the vehicle is in place. We have advanced driver assistance programs that can perform certain critical tasks whilst driving far better than a fully alert driver ever could. Our collision avoidance technology would beat a fighter pilot every time, even a South Korean fighter pilot. I personally have been parking large SUVs for 28 years, and I consider myself very good at parking large SUVs in difficult situations, but I cannot match the parking capability of my Range Rover. So my point really is that things have progressed, and the data flows between the vehicle and the manufacturer and the operating systems of the car are already more than we could have imagined only a few years ago. But the sheer amounts of data passing in both directions offers far greater opportunities with AI. So let me talk a little bit about how a couple of things that we think are key to unlocking those opportunities. This is a summary of our industrial footprint. So the first thing I'm going to talk about in terms of unlocking opportunity is really about people. As a company, we have two main design and engineering centers, both of them in the United Kingdom. We have 10 assembly plants around the world. But the critical point on this slide are the 9 technology hubs. And the reason that that is important, we employ about 40,000 people, probably about 200,000 people indirectly. We have 9,000 engineers currently in our team. But we have about 1,100 of those engineers are deployed across the 9 technology hubs. And unlike other elements of our business, they are not situated where we build the cars. Those technology hubs are situated where, in the location where the best people are developing technology at the greatest speed. So we have technology hubs in Asia, we have technology hubs in Europe, we have technology hubs in the Americas. 3 of those technology hubs opened this year. And we are constantly working on building up the capability of our engineering teams to deal with the digital and the data revolution that we're currently experiencing. It's also important that that workforce, those new engineers that are joining the team, also reflect our customers in their diversity. The expectations of a consumer in Asia are very different from the expectations of a consumer in Europe or in the US. Their outlook on life, but also, and critically, their relationship with technology. As somebody that's moved from the West to South Korea, one of the first things you have to do when you arrive in South Korea is you have to relearn the digital landscape, which is quite different here. And that is something that, as a global manufacturer, we have to take into account. So that's the first thing, is about how we build up our teams, attract new talent, and diversify our workforce and the skills that we are onboarding. I think the second thing really for me is about partnership and networking. You can't build networked vehicles unless you yourself are networking. So we continuously build up really critical strategic partnerships with the best people in the business. We announced recently that from 2025, all new vehicles will be built on using NVIDIA's Drive software-defined platform that won't just deliver amazing technology and solutions in 2025, but will also mean that those vehicles are future-proofed. So as technology advances, we will be able to deploy new features and capability onto those vehicles. We have partnered recently with a European company, Everstream Analytics, whose speciality is on capturing data from the supply chain and then using AI to improve our performance. And I'll talk a little bit more about that in just a second. And then the third example I wanted to give you, in 2016, as the technology revolution was really heating up in automotive, we began our own venture capital arm, which we call InMotion. And InMotion they're venture capital. They go and invest in specifically in businesses which are specializing in AI and the application of AI in mobility. So they have a broad portfolio of companies that they invest in. They include Apex AI, that's a safety critical AI software. a company called Voyage in the US who are building autonomous shuttles for US retirement communities. Now, they have a broad range of investments and partners, but what that enables us to do, as well as achieving a substantial or potential return, is connect and learn and understand and communicate at the cutting edge of the AI industry. We have talked at great length about what disruption really means in the car industry. And we've talked in the last years, we've talked about, is it about autonomy? Is it about different forms of mobility? Is it about ride sharing? All of those things are absolutely, is it about electrification? All of those things are, of course, critical to what's happening in the automotive industry just now. But I would like to just give you a more general definition as I see it, which is our disruption, our transformation is really about data. It's about the sheer amounts of data that we have available to us that we did not have before. That data that, when paired with AI, opens up an incredible wealth of opportunity. Things that were science fiction until very recently. One estimate showed that a connected car today, and most vehicles that are sold today are now connected, but an average connected car is already sending and receiving over 600 gig of data every single day, and that figure is growing rapidly. Now, three things have really intersected that allow this data, this technology revolution to take place. The sheer speed with which we can operate, so the computational power that we now have at our disposal, but also the data speeds through 5G or Wi-Fi. Cloud computing, and then also the incredibly powerful processors that we can put at the heart of our vehicles. Processors that can now both receive, send information, operate the appropriate algorithms, but then critically can carry out mechanical functions, can drive software that will actually change the mechanical performance of the vehicle. And then finally, with the data and the speed in place, we have the maturation of AI enabling our software-defined vehicles to process the incredible amount of information that's coming in and do something valuable with it. The poster child for AI tends to be autonomous driving, but I really want to emphasize that AI is already a crucial element of our business and of our operation right through the value chain. And if you will allow me, I'm just going to give you some examples of how that is happening, or indeed projects that are currently in place and under development. So if I start at the top with design and production, the application of AI in speeding up design workflows, rapid prototyping, and then critically the test cycles have the opportunity or create the opportunity for us to significantly reduce the time to market. Another example of where AI is assisting in our manufacturing processes is the current situation and also the potential of collaborative robotics or cobots. They're already in use in our plants, so you're used to seeing images of large-scale robots improving precision and productivity in our factories, but they're typically caged, automated. Of course, with cobots and the use of sensors, those robots are much smaller and have now the ability to actually interface and work in close proximity to human beings rather than within a caged environment. I touched on supply chain before. I mentioned our partnership with Everstream Analytics. I kind of get that supply chain doesn't sound instinctively like the most exciting part of the AI discussion. But I have to tell you that during the COVID pandemic, the automotive industry suffered unprecedented disruption to its supply chains, to the point where those disruptions became, a very, very significant threat to their business. And in our case, we certainly learned the lesson from that as our supply chains are recovering. So we have partnered with Everstream Analytics. And what their job is to map and to embed AI into the entire supply chain. It means that JLR can monitor its supply chain in real time to help avert disruptions in the future. I'll give you a couple of examples of how that might work. So simply through collection of huge amounts of data, algorithms reviewing that data to check for anomalies and patterns that are associated with disruption. Allows us to take instant action to address it with human involvement potentially, but also enables us to identify the origin of the problem, which is often the critical challenge that we face. AI can also monitor natural language sources from the web and from other media sources. So unstructured sources of information can now be captured, monitored, and can identify potential issues, natural disasters, strikes, conflicts, that allow us then to take action and to respond to avoid disruption. Introduction of RPA and widespread use of RPA in robotics, learning, automating routine tasks in supply chain management has the ability to, the benefit of freeing up resource to do more value-added work, but it also eliminates data errors, improves productivity. And then finally, the introduction of sensors into machinery right through the supply chain provides real-time data, allows for predictive maintenance and avoids line stopping breakdowns. As we transition to a net zero or net carbon zero future, our commitment is to be net carbon zero by 2039. To do that, we have to reduce emissions by 54% by the end of the decade. And I must tell you that that is simply not possible simply by electrifying or even just by addressing your own direct manufacturing activities. To achieve that kind of reduction and to do it in a way that has real integrity, you have to do it right through the supply chain. And the only way to do it through the supply chain is with intelligent use of analytics and AI. Quality control. So our cars are talking to us. We're collecting information from our vehicles just now. In the past, and in the recent past, we had to wait for a vehicle to visit a workshop. We had to analyze, often manually analyzing warranty information in order to ascertain problems or patterns in vehicle quality. With the information that we're receiving just now and with AI, we can analyze that data. We can address issues and irregularities often before they have become a problem. It's also worth noting that with connectivity now, what in the past might have required an intervention or a recall, we can often now fix simply by uploading better software or updated software over the air without a customer visiting the workshop. This technology also critical going forward as we move to a BEV future. Because one of the keys to a successful transition to battery electric vehicles is the efficiency and the range and the management of the batteries. And the ability to connect to the vehicles, monitor that information, and then constantly improve the performance of our battery management systems will be critical. I'll give you a good example of that is that our Jaguar I-Pace, so the Jaguar battery electric vehicle that we launched 3 years ago, we recently provided an update to customers that added further 20 miles of range to that vehicle simply by the use of analytics that showed us how we could better manage the battery performance of existing vehicles. So your car is actually getting better, and the autonomy of your vehicle is actually getting better over your ownership experience. Another example of that and how we improved ownership experience is we recently deployed Alexa AI assistant globally to our customers. So customers who'd purchased the vehicle without that technology woke up one day to find that their car had received that technology in an overnight software upload. So it just gives you an example of how we can improve the ownership experience. And then finally on driver assistance, I've mentioned already that our vehicles will all be equipped with NVIDIA's Drive platform going forward. That will enable an increase in advanced driving features and driver assistance. Interesting to note that Waymo, who are the Google or the Alphabet-owned autonomous driving robot taxi company. They're currently operating a fleet in California quite successfully. That fleet is entirely made up of Jaguar vehicles. I think there's 250 Jaguar I-Pace running a fully autonomous robot taxi service in California as of today. We're already, I think, achieving quite a transformation in terms of the occupant experience. I mentioned the AI assistant that we've added to the vehicles. Here in South Korea, we were the first manufacturer to integrate TMAP into our vehicles. Natural voice commands transform the occupancy experience. But if you allow me, I will just maybe end on one example or one project that we're working on that kind of caught my imagination. And it's also an interesting example of how brand intersects with the application of AI. When our designers and engineers are working on our vehicles, I take the example here of Range Rover, they often use this expression, tranquil sanctuary. They want to create a beautiful, comfortable, quiet, safe environment for their customers. You should feel a particular way if you're driving or if you're a passenger in a Range Rover. And the project that we're looking at just now is to look at how we integrate sensors into the cabin. Sensors that are able to detect if a driver is fatigued or if a passenger is fatigued. Sensors that are able to detect the mood of the driver. We saw some research recently that suggested that around 74% of people feel very anxious or very stressed at any particular point during the day. We know a lot more now about wellness and the impact of somebody's environment on their general sense of well-being, which led us down a path of thinking, well, if sensors can tell us how a customer or how a passenger is feeling, then we can make the machinery adapt. We can make the vehicle adapt to really create that tranquil sanctuary. That could be simply through media choices, automatic media choices. It could be by setting the recline on the seats. So if a passenger is tired on a long journey, we can automatically configure the vehicle to enable that customer to fall fast asleep. We can change the lighting in the vehicle. We can change the temperature in the vehicle. All of those things in order the air quality, all of those things just to create that tranquil sanctuary that responds and learns how to respond to a customer's needs. I just talked to you a little bit then to finish about some of the challenges that we see ahead of us. Some of the issues that we would need to address. I mentioned at the beginning of my talk that AI has the power to do a lot of good, reducing accidents, improving traffic flows, reducing emissions. But it, of course, raises certain ethical and societal questions. It means that the pace of development in the auto industry is a question not just for car manufacturers, but also for society and for government. So working in lockstep with government on regulation and partnership between industry and government, we see as being a critical factor in how the industry progresses in the coming years. The second thing I touched on were people and skills. That may be very relevant to people in this audience today, but the need for digital and advanced engineering expertise is really accelerating. So in recent times when there was a lot of layoffs going on in tech industries in Silicon Valley, for example, Jaguar Land Rover were very quick to get in and to hire some of the top talent into their business, and that constant search for people with the right skills and expertise to join the company as we go through this transformation is fundamental. The third consideration, I think, is really going to be one of cost and ultimately pricing, because whilst we can do more and more and more with the cars and with the technology and the framework, that also escalates the cost. If you're planning on fitting, sensors and very sophisticated processes into your vehicles, then it increases the cost. So we do consider how our business model will shift going forward, and to what extent certain attributes, features, technologies will be purchased by a customer potentially on a subscription basis. So rather than the old business model where you simply buy the car, you specify your vehicle, you choose what you want, the option going forward to subscribe to features during the course of your ownership experience will, I believe, be there. It also means that in future vehicles can be continually improved and can be continually upgraded during their lifetime, which we think would have a very positive impact on whole life costs and residual value. I think the fourth consideration I would raise is just one of trust. Jaguar Land Rover as a company, Land Rover, Range Rover as a brand is nothing if it is not a trust mark. People have to trust us for our brand to be strong and to be relevant. We don't believe that customers want to be part of an experiment. They trust us to apply technology that is mature, technology that is safe, and technology that has real-world application and utility. They also need to trust us with their data. So they need to be confident in sharing information and confident that they will not be exposed to risk, which is why I would say that in this age, and particularly in automotive, cybersecurity is critical for us and for our clients. I hope that has given you a quick and useful overview of my industry and also where Jaguar Land Rover is on its journey. It's been a great pleasure to speak to you today. 감사합니다. Thank you.
네, 감사드립니다. 훌륭한 특별 강연을 제작해 주신 로빈 콜건 대표님께 여러분 다시 한번 큰 박수를 보내주십시오. 네, 감사드립니다. 자, 계속해서 이어지는 다음 세션의 대주제는 AI 모빌리티입니다. 여러분들도 잘 아시는 자율주행과 관련된 주제가 되겠는데요. 우리 피부로 느끼
First session of the fourth session. Let me introduce you from the first lecture. The topic is autonomous driving, technology and market trends. Currently, the self-driving car market is growing rapidly worldwide with an average annual growth rate of more than 40%. The market size is expected to reach up to $400 billion by 2035. In this response, Director Tang will give a lecture on trends in technology in each field related to autonomous driving and improvements to rapidly changing systems. Let's welcome General Manager Jeong Gwang-bok with a big hand. Hello, I am Jeong Gwang-bok from Korea Autonomous Driving Development Innovation Foundation. I will introduce myself briefly, and I will omit some of the slides if I have to. I did not major the hardware sector. I've majored software and road civil structure, and also I studied smart city, and there were 4 projects for smart city: Sejong, Busan, Daegu. Busan and Sejong is still the trial complex designated by the government, and Siheung and Daegu has almost completed its construction, and especially Sejong has a concept of autonomous driving, and that's how the city has been planned. And the most important point is having a vision to make all the vehicles in Sejong area to autonomous. So people living in Sejong will drive autonomous vehicles. And by that time, I have moved to Korea Autonomous Driving Development Innovation Foundation. And this is a project done by 4 different ministries. One is Ministry of Industry, one is Ministry of Science, ICT, and Land and Transportation, and also Police Department. And there's a Korean proverb that if you listen to something that you do not know about for more than 3 years, then you will become an expert after 3 years. So I think I have learned about this system quite a while. And I will briefly explain the project of our foundation. And our goal is to complete level 4 by 2027, and our plan is to complete the commercialization foundation by 2027. There are many ministries that are participating in this project, and Ministry of Industry do not produce autonomous vehicle, and the focus is to make development that can localize the autonomous vehicle. And Ministry of Science, ICT is focusing on communication, and Ministry of Land and Transportation and Police Department is focusing on road and infrastructure. The purpose of the project is to become the top 3 global autonomous driving technology power through package type convergence technology development. So far, the US is ranked at the top, and next there is EU, Japan, China, and Korea. And our goal is to overrank Japan, but after COVID-19 pandemic, China had grown to rank number 3, so it is our goal to outrank China soon. And we also need to improve the perception of people on autonomous vehicles, because some of people do not think autonomous vehicle is safe enough. So through technology development, we are planning to expand the market and approach close to people and make people feel safe about autonomous vehicle. And also we are working on standardization of autonomous vehicle. We have been invested about 1 trillion won, and the period is from 2021 to 2027. And 5 stages had already been launched, and we only have 2 tasks left undone. And we are still developing very fast with technology. And we planned this program in 2018, and we always need to make new plans so that we can follow up the new technologies. And there is a 5 task that is related to feasibility test, and we are also working on the projects that is based on accident-oriented data and also accident-related data. And also, we are focusing on accident prevention data set. And there are 3 projects that will be starting next year. I will briefly explain you about the autonomous driving technology market. And this is from Precedence Research. The number was about $126 billion, and that number had grown to $180 billion so far. And this is the estimation. This year, according to global consultant group McKinsey, said that by 2035, the autonomous vehicle sales will grow to $200 billion. And also, commercialization of startups and R&Ds will be continued, but in a different direction. Last year, Argo AI, which is autonomous driving platform, announced the stoppage of their business, and investor is so we are now focusing on startups. And if we look at the current status and trend, we are still developing. And in order to make the full commercialization, it will take time. And we are planning to accomplish level 4 by 2024. But it will be very difficult for us to accomplish by 2027. Our goal is to make foundation by 2027. So by 2030, we are trying to make sure that autonomous vehicle level 4 will be on the road. According to KPMG, we are expecting about 4% growth annually, and not just the vehicle, but also the sensors and semiconductor. The number of it had grown dramatically, and we are expecting the market for sensors and semiconductor will also grow. And as for European countries and China 50%, European countries 50%. They are planning to make autonomous vehicle obligation mandatory for by 2030. And we are also expanding and supporting the market. As for Google, Microsoft, and Apple, the autonomous vehicle testing is implemented in various methods. And if you look at the graph on the left, there were some monopoly in the market. Volkswagen and Toyota, Benz, Nissan had took the market, and also there are many startups that are preparing for the autonomous vehicle market, but it is still focused on some vehicle companies. And we are expecting the market to grow in the future. And by 2021, it was about 3.6 billion won, and it will grow to 26.1 billion trillion won by 2035. The ratio of 7%, which is taken by Korean vehicle companies, we still need to invest more for the technology development. This is a market entry of autonomous driving technology, and this is presented by guide group. So there's leader group, competitor group, challenging group, and following group. Challengers group and followers group. The assessment is made to the companies that are expected to launch autonomous vehicle in 10 years. So they assess quality, credibility, and the total score is 100. Generally, Tesla is at the end, which is opposite to our expectation. And also, Mobileye had a different rank after Q1 assessment. As the autonomous technology had emerged, the importance of IT and component is also growing. So the industry trend is changing very fast, especially for completed vehicles, which is ADAS-based vehicle, are mostly developed. However, ICT companies like Google, they are focusing on LiDAR and sensors, or also high precision map. So they are focusing on level 3 or higher level, which is fully autonomous vehicle. We don't see any companies of automobiles, but there are some collaboration between IT companies and automotive companies. Google Waymo is currently providing paid service, and they are ranked #1 3 years in a row. And this company has radar and LiDAR, and also it is implementing autonomous driving based on the system. So they started the robotic taxi a few years ago, and they are also operating unmanned robot taxi. And also China is growing very fast, and at the center there is a company called Baidu. Baidu followed Waymo, and Baidu started unmanned taxi after Waymo. And after a few years, Level 4 RTE6 had been released, and in 2023, Baidu is planning to operate more than 3,000 taxis. Amazon had merged with the vehicle company, and they are currently implementing tests in the US. And also, AI semiconductor business, NVIDIA has various sensors and also computing sensor equipped automobile in development, and they are providing this technology to 25 companies. Intel and Qualcomm is also planning to make a mass production, and they are implementing their plan very fast. Now I will explain the technology trend inside autonomous driving vehicle. There are many sensors in autonomous vehicles, so the combination of sensors will make vehicles to sense and recognize. So it is eye for human, eyes for human. So these sensors make possible for automotive to sense the environment, and the combination of sensors and layout of sensor will make a difference, and this different layout design is one of the important factors. So in order to have the optimal sensor layout, we have to consider the physical property, and then it should compensate with other sensors. So you have to know the precision, you have to improve the precision, and by duplicating the sensors, so with the redundancy sensor system, if one sensor goes down, the other sensor can sense the environment so that it can continue providing the perception. So it is considered by it is the physical limitation is considered to make the full layout. So the sense scope is all different, and data collection time is different, and also resolution is different. So there are some limitations for the sensor that can be equipped on a vehicle. So in order to make automotive that can self-drive, we should have LiDAR, but LiDAR is very expensive, so we have to come up with a sensor that can be mass-produced so that it can process a huge amount of data, and it should also consider the environmental condition. But the existing sensor has limitation, so it is very difficult for us to expect mass production of these vehicles with these sensors. As for the automotive companies and startups, they have their sensor combination, sensor equipment location, and they are also testing the safety of their layout. But so far, there is no full completed layout that's proved with the safety. Next is autonomous driving technology trends. Last year, EU implemented a new regulation which is making all vehicles to be equipped with ADAR, and this will be applied to all vehicles starting from 2027. So what is most important is camera and LiDAR. Camera and LiDAR technology is very important, so technology is fastly developed in this field, and market is fastly growing. So according to the analysis result of this field, LiDAR patent take about 37%, and before 2013 there were numerous patent registration application for LiDAR, but now it is focusing more on camera. In order to distinguish objects, AI is combined with camera, and camera cost is lower than before, so that is the reason why there is a combination patent. Camera patent is mostly applied by Japan, and LiDAR is mostly applied by the US. This is camera. Camera is mostly applied in order to sense the environment, and this is very affordable. And if you have the right software equipped, you can see the dynamic and static object at the same time. And it can also provide color video, and the sensor system can know the environment such as the road condition, and this camera system is mostly used. As for cameras, cameras are very much affected by lightings and weather conditions. So if it rains too much, or if there's not enough light, and if there's any bad condition for this visual sensing, then the result quality is not good. So according to our investigation, when it rains, the camera function will go down to 0. So to compensate this situation, we are using LiDAR and LiDAR. So LiDAR is using electronic wavelength, and it is reflecting that signal and also receiving the signal. So these all go through a signal processing system, and it removes noise and then applied. Radar that is applied currently is mostly 24 or 79 gigabytes. So compared to 24 gigabytes, 79 gigabytes has a better angle and better velocity. As for 24 gigabytes, there is a frequency usage issue from the European countries, so the gigabyte is now expanding. So radars do not get affected with weather conditions, so it can also function well in a bad weather or bad lightings. However, as for radar, it can wrongfully sense a metal object, and it can wrongfully sense the static object. Recently, it can also sense the vertical angle and with the 4D technology. Next is LiDAR. LiDAR is using the sensor, and LiDAR sensor wavelength is about 205 nanometer and about 1000 nanometer. And these are very easy to mass produce, and the power usage is very low, and also it can absorb water, and it is very much less affected by water. However, this is very sensitive to photovoltaic noise, and as for 1550, it has some controversy with the visual damage. LiDAR has bad function in bad weather condition and bad lighting condition. So we are also developing other type of LiDAR that won't get affected by weather condition. And also, this is information based location information. So driver do not intervene, and if we want to make level 4 autonomous driving, then we have to go beyond radar, and it should have high precision location. and also high precision mapping technology is necessary. So we also have mapping technology and location technology. Precision GPS is very important, and industry knows that. The price of RTK device is lower than before, and also the media that is sent through the device is now various. And in 2025, in a few years ago, Hwasong had a driving testing, and we are providing a autonomous driving testing, and here RTK GP testing is utilized. I have skipped some of the slides, and this is autonomous driving recorder. This will play an important role when there is a car accident. Currently, there is an EDR that is recording the accident, and that is used to analyze the accident. DTG is constantly recording the situation, and accident recording device, which is EVDR, is also utilized. As for driving recording device, there are many regulations that are made currently, and also there are international standard that is stipulated, and those will be enacted soon. Autonomous driving accident, the number of accidents will grow, and when there's one accident with death, then that's a big issue these days. But I cannot say autonomous driving is accident-free. And if autonomous vehicle is commercialized, we have to expect that there can be some more accidents related to autonomous vehicle. But this may lead to people's perception with the thought that autonomous vehicle is not safe. So in order to analyze the accident, we can collect data that is printed by the system, and also collect the recording device. And also, we need to make a linkage with the data, and we should have a system that can analyze the collected data. This is a standardization activity related to autonomous driving recorder. This is CITS VTX, which is related to communication. I will skip this. As for autonomous driving, Tesla is moving toward full autonomous driving. As for Korea, the reason why the government is supporting autonomous driving is because there are some limitations just by developing autonomous driving. So the goal is to ensure safety by enforcing infrastructure and road. I mentioned level 4, but there are sometimes level 4 plus. Level 4 plus means that we are willing to utilize the infrastructure information. With ITS project, there were many road projects related to autonomous vehicle. We are currently implementing projects that is linking vehicles and roads, and if the vehicles cannot sense the situation, the infrastructure can help. And we are developing system for the better safety. And that system will going to communicate with each other between cars and between car and infrastructure, and this communication speed should be fast and it should be secured. So also communication technology is under development. 5G was mentioned a few years ago. I don't think we are applying 5G to autonomous driving yet, but government is currently working on research related to 6G and autonomous driving. This is autonomous driving technology level and gap by industry. So the top is the US, then there's Europe, China, Japan, and Korea. As for the United States, in 2011, the first approved autonomous vehicle was launched in Nevada. And after that, US autonomous driving related laws and administrative orders were enacted, and companies are supporting actively in this matter. As for Korea, Korean people, compared to the US, Korean people do not care about their privacy issues that much because we are always exposed to surveillance cameras. But in the US, there is not that much surveillance cameras as much as Korea because of privacy issue. But autonomous vehicles should be equipped with cameras, so there are high concerns of the privacy and personal information protection. If you look at the left side, this is the areas that are actually implementing the autonomous driving testing. And in Michigan and CCAT, they are operating MCT complex. In May 2023, Google Waymo is started operating autonomous driving taxi service. And they are also working on the logistics, and they are developing technologies related to logistics. Autonomous vehicles were not developed because of the car owner. It was developed for the vulnerable group. And if you want to provide service, you have to be profitable. And there are already taxis and buses that is already commercialized. But if you think about the deficit and if you think about the government subsidies, then we still need to think if this taxi, unmanned taxi, can play its role. So from the public project perspective, you have to concern about people, but for the private companies, they cannot ignore the profitability, so that is why they're concentrating on logistic technologies. European Union is also coming up with various strategies. They are suggesting infrastructure, safety, and job creation. As for Germany, Germany is fastly reorganizing the law and regulation. And the law and regulation for transportation was focusing on pedestrian only, but now it has divided into holder, technical director, and manufacturer. So when there is a vehicle, there can be vehicle owner, and I mean, you've heard about the technical director. And there's also manufacturer, because manufacturer should be accountable for the safety related issues. Germany is also sensitive with privacy issues, so they are enacting regulations and laws related to transportation and driving. And next, let's move on to the UK. United Kingdom has CCAV, and they are implementing in 6 different areas. And when there's autonomous vehicle adopted, the law and regulation is already prepared. But what is different is Korea is already giving benefits for autonomous driving. So when you start driving, you can make a phone call while driving. But in the UK, cell phone usage is prohibited. At level 3, when there's an issue with the vehicle, man should intervene right away. But cell phone is not equipped on the vehicle, so there is a chance that the individual is concentrated on the cell phone. And if control right is transferred, the connection should be stopped, but this does not apply to the UK, so it is not allowed to use a cell phone in the UK in autonomous driving. Next is China. During COVID-19 pandemic, China was very closed when it comes to developing the technology. They were very active and aggressive because as for Korea, when we make a technology that is related to autonomous vehicle, we have to consider law and regulation related to transportation. But in case of China, when there is a illegal parked vehicle, the case is different. Because in Korea, when there is an illegal parked vehicle, the autonomous vehicle will stop. It will not go and pass the line. But as for China, it is okay to violate the law and then pass the line. And in Korea, in a child protection area, man should drive the vehicle. And in Korea, there are many regions for child protection, and we are expecting human intervention because of these areas. Japan is preparing hard, and they are focusing on highway zone first, and then they are moving on to logistics. And without any institutional improvement, they commercialized first. So Korea is also following the suit of Japan, and we are benchmarking Japan's case. Japan has GM, Cruise, Honda. And they have this autonomous driving free shuttle, and they are preparing taxi like service. Korean government is actively supporting and providing subsidies for these projects, and like I said, level 4, there are the regions that can conduct autonomous vehicles, so we are preparing and developing technologies related to level 4. By this June, we conducted testing in 16 cities, and 9 cities were added after that. In Gwangju area, unmanned vehicle testing is still ongoing. This is government policies. This is autonomous driving consumer perception. According to the survey, it turned out that consumers do not feel the autonomous vehicle is safe. So our foundation's goal is to reach 80% of acceptability, but from the perspective of people, they think level 2 and level 3 is only safe. And the vehicle will be developed in software sector, like Land Rover. You are focusing on software, not to the vehicle. I am sorry I have skipped so many contents in my material, but if you refer to the webpage of our foundation, we are reporting reports, and my plan was to summarize that report, but it was not a summary. Please refer to the issue report that we publish, and if you have any question, please ask the foundation so that we can provide you with the answer. Thank you so much for your excellent lecture. Thank you so much, Director Jung Kwang-bok, for your lecture. Thank you. I will introduce the next lecture. Electric vehicles are very interesting, and artificial intelligence and electronic vehicles. And head Lee Chol-young of SK Signet said he had prepared AI-based EV charging technology trends and charging service business model.
Hello, good morning. My name is Lee Chung-yeol, and I'm actually from Monit, which is around the EV charging system. So the charging cannot be separately thought with when it comes to EV, right? And I would like to share with you some of the explanations and some cases as well. I'm gonna go very fast and brief. So here's the agenda. I'm gonna talk to you about the mobility charging industry, and I'll be also sharing with you some of the businesses and service models. And if you see the charging industry's characteristics, I mean, when it comes to e-mobility, e-mobility represents the mobility that utilizes electricity. And if you look at the ecosystem, there'll be the electricity producers and users, payments, related to platforms. So all these various industries are intertwined, and ultimately, industry delivers the final value to the e-mobility users. And as we see the emergence of e-mobility, you see there used to be the boundaries in the industry, but we no longer see such a clear boundaries. Before, there used to be the petrol stations, as well as the petrol providers, and there are manufacturers, users. But because of these disappeared boundaries, you see that the different players started to be involved in overlapping industries. So as we see this e-mobility ecosystem, in particular, I mean, once again, the characteristic would be boundless nature, where different players are involved in overlapping industries. And if you look at the charging infrastructure regarding the location of the charger, it has to be connected with the energy sources. So relating to that, they're connected businesses, that is to optimize the energy supply and demand and operation. So along with this charging system, there will be connections with the grid and ESS. And if you look at the charging technology trends, I mean, I believe that this area is the one that grabs a huge interest of all the stakeholders. I mean, starting last year, EVs started to gain more and more popularity. And to overcome the limitations that EV once had, battery capacity started to grow. And that means that there needs to be a better charging system that can accommodate this maximum grown charger capacity. And see now, we see that for the 350 kilowatt charger, luxurious vehicles and e-buses or trucks, these high output vehicles will be using that, and for the general vehicles, they will be using the charging power of average of 100 to 150. And you see all the charging techs are encapsulated in this page. And as I mentioned, that there's a fast charging and there's V2G charging, and maybe in the future there'll be wireless and robotic charging and battery swapping system, or the multi-socket system, pantograph, automatic charging method, or even the automatic charging for the autonomous vehicles will emerge. And if you look at the fast charging, I mean, if you look at those 350 kilowatt part, the cable that you see now is used. I mean, to increase the output, there needs to be a thicker line which cannot be carried by humans. And as you can see in the graph below, if it goes over 20 pounds, humans cannot carry. And if you look at the cables used for 100 kilowatt, I mean, it is even quite heavy for women to hold. So there's this cooling cable that's been used. So there's this part that there's lubricant is used, and if you see with this structure, the fast charging became possible. And with this innovation, people started to use fast charging. And as I've mentioned, if you look at the autonomous charging, now we are at the stage of level 0. And starting last year, actually, the plug-in charge, which is level 1, started to be implemented. That is, humans need to be engaged in terms of connecting the device and the vehicle. So starting Hyundai and other European manufacturers started to adapt this, and the level 2 is about park and charge, which includes the overcharge. And if you go beyond that, there will be level 3. And level 4 means that autonomous vehicle will be able to be charged without human interruption. So OEMs are now working on developing these autonomous charging technologies. You see the image on the left is the way that Volkswagen is working on. So you see there's a battery source and there's a charger, and on the front of it there's a robot that would drag this charging pack that would allow this automatic charging. And you see next to it there's a robot charging system that is being tried by Hyundai, and you see this charger moves and then the car will be charged. And below, I think this method is pretty similar to Hyundai. This is the way Tesla used. And if there's one differentiator, I mean the existing model, the power is connected, but for Volkswagen, in terms of efficiency, I believe that in terms of operation and cost, it is advantageous. And if you look at the auto charging for the buses and trucks, and on the right, if this is what we call the pantograph, you see when the buses comes in, then this pantograph method would use the docking system, and on the left is the multi-connect system. You see, just like the airplanes are getting their energy sources in air, on the funnel the charger will be connected, and these can accommodate a large volume as well. And the one that you're seeing is the charging on road. There was a pilot project in Korea, and just like the way tram moves, the vehicles will be able to do charging on the road with the system. And there's also wireless charging system that's been studied, and this is what it's applied to the vehicle. There's another wireless method in the parking lot, and there's battery swapping method. It's used in China, and this is used for these electric two-wheeled vehicles. So this battery swapping method is already implemented in Seoul, and there's a company called Koro in Taiwan that is leading this area. And there's another technology called V2G. I mean, if you think about 60 kilowatt battery, if you think about the average mileage, there's always an issue with the battery capacity, right? So this method allows people to sell the remaining energy to the market. So the EV vehicle with this method will be able to play as even an energy supplier. And by 2025, I believe that this will be reflected in the regulations. And as I've mentioned, if you think about level 1, this is what the level 1 technology, PNC, is all about. This certification is not done by the physical card, but it will be using what's embedded in vehicle. So it's just like, the way we do online shopping. And Hyundai is very much specialized in the technology, and they're doing the pilot project. And studying last year, they started to incorporate this PSA technology. So if I explain to you about these business models, these charging business models is as follows. Not just a particular operator. I mean, there's no boundary. It's very boundless. So the utility supplier now can also become the energy suppliers, and EV manufacturers like Tesla, Hyundai Motors. They can even handle their own charging services. So you see, once again, there's no boundary in this area. And if you look at these business characteristics, I've been saying about this multiple times. I mean, this utility market used to be monopolistic, but now it's shifting towards more of a fragmented market. And because there's a disappearance of monopoly, the P2P business operators, roaming operators, and all the players now seen as the new players, and they're all mixed in this market. And this is the huge differentiator. And when it comes to the tech competition, it will be about this fast charging or MSG, and as well as for the standardization. I think you may have seen in the news, Tesla, as they introduced their standard to NACS, their standard is actually rising as the general standard in the market. And this is the service model. As mobilities become serviced in the existing environment, vehicle used to be a mode of transportation, but now mobility is becoming more of a means of providing service. And as we move towards this direction, data, AI service, these areas being emphasized more than before. So the driving patterns or the even consumption patterns, these will be stored as data that can be used to increase the convenience of the users. And I believe we will see more of these services in the market. So transportation and transportation infrastructure and mobility service, all this combined how we efficiently improve mileage, how we make it more convenient, and how we make it more smarter will be the area of focus for the industry players. And as I've mentioned, the trend's been changed. It used to be means of transportation, but now we're shifting towards mobility services. And if I give you one example of Mercedes, with EVs, there's delivery services provided, and before the last mile was the major focus. So you can understand it as moving or mobile convenience store. So if the vehicle moves to a certain point, then from that point, drones or bikes, other means of transportations will be used for finalizing the delivery. And this is around the logistics. And this is Ford's case. They are using the plug-in hybrid. So according to the mileage, the charging can happen during the nighttime, and then the urban mobility will be done by electricity, and the outer skirts will be driven by engine. In case of Netherlands, up to mid-miles, the engines will be used, but in the central part for logistics, only EV-driven trucks should be used. So if you think about this case, all these convenience stores delivery is made by these super small scale vehicles. And this is a pilot project actually. And utilizing the e-bikes, I mean, after they load packages, these bikes will be used for the area where the cars can not get in, and or even this can be used for the urban mobility. I mean, there are car restricted areas within the urban area. So if you think about Oslo, you don't really find a parking space in the city. So people carrying their e-bikes in their vehicles and use the e-bikes when they cannot use the vehicles, this is something that's quite common there. So this is the change that we'll see in the petrol station. So if you look at the petrol station, you see there are petrol stations that have both petrol chargers and the electricity chargers for the EV cars. And this is again part of the pilot project. GS Caltex, SK Energy, these providers. And as for the SK Energy, they are even operating a petrol station where they provide a hydrogen charging system. So this is what this convergence and integrated system is all about. And this is the one that I explained. It's a swapping system and it's very much active. You would find it not just at the petrol stations, but in front of the convenience stores where students can also easily use. And because the location-based service is provided, the delivery riders, according to their driving characteristics, if they, for example, fast drive, there will be some disadvantages. So this data service is also being provided. And that wraps up my presentation. I made it really short as my previous presentation was relatively long. So that's it for me now. Thank you very much.
Thank you so much for your wonderful presentation. Let's give a big hand to Mr. Lee Chun-yeol for his excellent presentation. This completes the fourth session of AI mobility. Thank you so much for your meaningful lectures. After listening to an interesting topic again today, lunchtime is already approaching. I will inform you about lunch break. Participants will have lunch from now until 1 o'clock, and we will continue with the next section. Today, exhibitions of various domestic AI companies are being held in the lobby of Oryong Hall, so we ask for your active engagement. After enjoying your lunch, please come back to Oryong Hall for afternoon session. Thank you.